On a clear night, when the world has grown quiet, Orion rises slowly above the horizon. Its shape is familiar, even to people who do not know the names of stars. 3 stars form the belt. Other lights mark the shoulders, the knees, the outline of an ancient hunter standing in the dark. And on one shoulder, glowing with a soft reddish color, there is Betelgeuse. To the naked eye it looks simple. A point of light. A small ember in the winter sky. It does not seem restless. It does not seem fragile. It does not seem like something changing. But the stillness of the night sky is one of the oldest illusions human beings have ever believed. The stars look fixed because our lives are short. They seem eternal because their changes are slow. They appear silent because space carries no sound to us. Yet above us even now the universe is moving. Stars are being born. Stars are aging. Stars are losing their outer layers into the dark. And some stars, after burning through the bright strength of their youth, begin to approach the last and most mysterious chapter of their lives. Betelgeuse is one of those stars. It is not just a red light on Orion's shoulder. It is a vast dying sun swollen beyond ordinary imagination. It is a red supergiant, a star so large and unstable that its outer layers drift and pulse like a deep cosmic ocean. For centuries, people have looked toward Orion and seen Betelgeuse shining there. Ancient observers saw it. Sailors saw it. Farmers saw it. Children saw it from cold fields and quiet windows. It belonged to the familiar architecture of the sky. It was part of the way night arranged itself above Earth. Then, in late 2019, something changed. Betelgeuse began to fade. Not vanish. Not disappear. Just fade slowly and strangely, as if the red giant had drawn a veil across its own face. Astronomers watched its brightness fall lower than expected. Amateur stargazers noticed that Orion looked different. A star that had seemed constant for generations had become uncertain. For a short time, the world looked up and wondered if it was witnessing the first sign of a supernova. Perhaps the giant was reaching the end. Perhaps the red shoulder of Orion was preparing to burst into a new light. Perhaps the sky was about to change in a way no living person had ever seen. But Betelgeuse did not explode. The night sky did not open with a second dawn. The star slowly brightened again. Its red light returned, though the mystery did not leave with the darkness. Something had happened there. Something large enough to be seen from hundreds of light years away. Something had moved across the face of the star, or risen from its surface, or cooled in its outer atmosphere. A shadow had crossed a giant. A wound may have opened in a place too distant for any hand to touch. A cloud of dust may have formed from material the star itself had released. And for a while, that dust may have hidden part of Betelgeuse from Earth. This is where the story begins. Not with an explosion, not with fear, but with a fading light. A red star changed, and in that change it reminded us that the sky is not a painted ceiling above the world. It is alive with slow transformations. It is filled with stars that breathe, swell, dim, brighten, and one day return their material to space. Betelgeuse is still there tonight. It still glows in Orion. It still sends its old light across the darkness toward us. But now, when we look at it, we know something we may not have felt before. That red point is not permanent. It is aging. It is unstable. It is carrying secrets from deep inside itself. And one day, whether soon, by cosmic time or far beyond human memory, it will no longer be the same star we see now. Before we can understand that future, we must first move closer. We must leave the quiet ground of Earth and travel in imagination toward the red glow on Orion's shoulder. We must ask what kind of star can dim so strangely, yet keep burning in the dark. What was happening inside the sleeping red star on Orion's shoulder? Betelgeuse looks small from Earth. It looks like a single red point suspended in the shoulder of Orion. But this is only because distance has made something enormous appear gentle. If we could leave Earth behind and drift outward through the darkness, the red point would slowly begin to change. It would no longer seem like a dot. It would become a presence, a vast glow. A swollen star surrounded by an atmosphere so large and delicate that its edges would not feel sharp. Betelgeuse is a red supergiant. That name sounds simple, but it contains an entire life story. Red means its outer surface is cooler than the surface of a young blue-white star. Supergiant means it has expanded far beyond the size of ordinary stars. It is not red because it is weak. It is red because it has grown old in the way only massive stars can grow old. Its outer layers have stretched outward into space. Its surface has cooled enough to glow with a deep orange-red color. But beneath that soft color, the star is still powerful. It shines with an energy far greater than the sun. It is a dying giant, but not a quiet one. It is huge, luminous, restless, and unstable. If Betelgeuse were placed at the center of our solar system, where the sun is now, it would not look like the sun. It would not be a neat, bright disk in the middle of the sky. Its outer layers would swell outward across the space where the inner planets move. The familiar architecture of our solar system would be overwhelmed by the body of a single star. Mercury would be inside it. Venus would be inside it. Earth would be lost inside its red atmosphere. Even Mars would not feel safely distant. Some estimates stretch Betelgeuse so far that its outer reach would come close to the region of Jupiter. This is the scale of the star we see as a small red light. A star large enough to swallow the inner solar system appears to us as a quiet ember. Distance makes giants look peaceful. But Betelgeuse is not peaceful in the way a stone is peaceful. It is peaceful in the way a sleeping volcano is peaceful. It is calm only because we are far away. Its surface is not smooth. It is not a perfect glowing sphere. It is a moving ocean of plasma, with enormous currents rising from below and sinking again into the star. On the sun, convection makes patterns like granules across the surface. On Betelgeuse, the cells of motion may be so immense that only a few can cover great regions of the star at once. Some parts grow hotter. Some parts cool. Some regions brighten. Other regions fade. The star is always changing, even when we cannot see the details with our eyes. That is why Betelgeuse matters so much to astronomy. Most stars are too far away to reveal anything more than light. They remain points. Their surfaces are hidden from us. But Betelgeuse is different. It is close enough, large enough, and bright enough that modern instruments can study changes across its outer layers. It gives scientists a rare chance to watch the late life of a massive star before the final collapse. It is not only an object in the sky. It is a laboratory made of fire, gas, dust, gravity, and time. And because Betelgeuse is visible without a telescope, it belongs to two worlds at once. It belongs to science. And it belongs to human memory. A child can look up and find it. An astronomer can spend years measuring its changing light. An ancient observer could have seen it rising above the horizon. A modern telescope can watch its surface shift and fade. Few stars connect the human eye and the scientific instruments so beautifully. Yet even with all we know, Betelgeuse remains difficult to define. Its distance is not as simple as measuring something nearby. Its true size depends on where we decide its outer atmosphere ends. Its brightness changes with time. Its surface does not behave like a stable boundary. The more closely we look, the less it resembles a simple sphere. It becomes more like a red atmosphere without a clean edge. A star becoming loose at the boundary between itself and space. This is one of the reasons Betelgeuse feels alive in the story of the night sky. It is not alive as we are, but it changes. It breathes through its brightness. It sheds material. It carries storms larger than worlds. It grows old and public, visible from Earth, while hiding most of its interior from us. When we look at it from the ground, we see only ancient light. That light has crossed hundreds of years of darkness before reaching our eyes. The Betelgeuse we see tonight is not the star as it is now. It is a message from the past. A red signal from a giant whose present state is still on its way to us. This makes Betelgeuse feel both near and unreachable. It is close enough to be familiar. It is far enough to be mysterious. It is visible enough to feel personal. It is immense enough to make human life seem brief. And it is old enough to remind us that stars, too, have endings. But Betelgeuse was not always this swollen red giant. Once, long before humans looked up at Orion, it was a different kind of star. Hotter. Younger. More compact. Burning through its fuel with the fierce speed of a massive sun. To understand the red giant we see now, we have to follow it backward. We have to ask how a star becomes so enormous, so red, and so close to the edge of transformation. Every star begins inside a cloud. Long before Betelgeuse became the red shoulder of Orion, it was part of a dark region of gas and dust drifting through the galaxy. In that cloud, gravity slowly gathered material together. The gas became denser. The center grew warmer. The pressure increased. And somewhere inside the collapsing darkness, a new star began to form. For a time, Betelgeuse was young. It was not yet red. It was not yet swollen. It was not yet the unstable giant we see from Earth. It was a massive star, bright and powerful, burning with an intensity far beyond the quiet steadiness of the sun. Massive stars live differently from smaller stars. They are born with more fuel, but they spend it with much greater urgency. They do not save their light. They release it fiercely. A star like the sun can remain stable for billions of years, slowly turning hydrogen into helium in its core. But a massive star burns hotter. Its core is under greater pressure. Its reactions happen faster. Its life is shorter, brighter, and more dangerous. Betelgeuse was born into this kind of destiny. It was never meant to shine gently for 10 billion years. It was meant to blaze. It was meant to change quickly by cosmic standards. It was meant to move through the stages of stellar life with the speed of a giant flame consuming its own foundation. For most of a star's stable life, hydrogen in the core is its central fuel. Hydrogen atoms are pressed together until they become helium. This process releases energy. That energy pushes outward. Gravity pulls inward. For a while, these two forces hold the star in balance. The star does not collapse. It does not fly apart. It glows in the long negotiation between pressure and gravity. But the balance does not last forever. In a massive star, the core uses its hydrogen quickly. When the central hydrogen begins to run low, the star has to adjust. The core changes. The outer layers respond. Gravity begins to press inward more strongly on the center. Core contracts and heats. Around it, other layers may continue burning fuel in shells. Energy flows outward in new ways. The star begins to expand. This is where the quiet transformation begins. A star that was once more compact starts to swell. Its outer layers move farther from the hot core. As they spread outward, they cool. And as they cool, their color shifts. The star becomes redder. It becomes larger. It becomes less tightly held. It becomes a red supergiant. This is not a peaceful aging. It is not like a candle slowly becoming smaller. It is more like a vast body becoming unstable as its inner structure changes. The core is becoming more extreme. The outer layers are becoming more fragile. The star grows larger while the hidden center becomes denser and hotter. Inside, gravity is asking for collapse. Outside, radiation and heat push enormous layers into space. Betelgeuse is now in this late stage. Its red color is the color of age. Its size is the sign of a star that has expanded far beyond its youth. Its instability is the natural result of a massive star moving toward the end of its fuel. The surface we see is not a calm boundary. It is the outer skin of a system under deep pressure. It rises. It falls. It cools. It brightens. It releases material. It trembles with motions too large for our everyday imagination. If the sun is like a steady lamp in the middle of our solar system, Betelgeuse is more like an enormous red sea. Its surface is not still water. It is a moving plasma ocean, stirred from below by heat, pressure, and gravity. Huge currents carry material upward. Other material sinks back down. The star is constantly rearranging itself. This is why Betelgeuse can never be understood as only a point of light. A point of light cannot show its age. A point of light cannot show the violence inside its quiet color. A point of light cannot show the slow collapse of fuel, the swelling of outer layers, and the hidden burning of a dying core. But Betelgeuse is all of these things. It is a star that has already lived through the brilliant part of its life. It has crossed from youth into old age. It has become large enough to blur the boundary between star and space. And as it moves through this final red chapter, it begins to give itself away. Material escapes from its outer layers. Dust may form near it. Its light changes from month to month and year to year. The star is not simply waiting for a final explosion. It is already transforming. It is already losing pieces of itself into the dark. This is one of the most important truths about dying stars. Their deaths do not begin at the instant of the supernova. They begin long before. They begin in swelling. They begin in instability. They begin in strange rhythms of light. They begin when the star can no longer remain what it once was. Betelgeuse is in that long beginning. The final moment has not arrived. But the path toward it is already written into the structure of the star. Somewhere deep inside, the core continues its hidden work. Somewhere above it, vast layers of gas drift and churn. Somewhere farther out, material once belonging to the star may already be cooling into dust. And from Earth, hundreds of light years away, we see only the softened result of all this motion. A red star in Orion. A quiet ember in the winter sky. A giant in old age still glowing. But if Betelgeuse is already in its old age, what signs of that aging can we see from Earth? From Earth, Betelgeuse seems quiet. It glows in Orion with a reddish light, steady enough to feel familiar. But the light of Betelgeuse is not truly steady. It rises and falls. It brightens and fades. It changes slowly like something breathing in the dark. This is one of the first signs that Betelgeuse is not a normal star in a calm stage of life. It is a variable star. Its brightness changes over time. Some of those changes are gentle. Some are more dramatic. Some follow rhythms that astronomers have watched for many years. Others appear suddenly, like disturbances moving through the body of the star. The reason begins with the enormous size of Betelgeuse. A star this large cannot behave like a small, stable sphere. Its outer layers are too extended. Its atmosphere is too loose. Its surface is too active. Deep inside, heat rises outward from regions we cannot see. That heat moves through the star in great currents. Hot material rises. Cooler material sinks. The process is called convection. On the Sun, convection creates small patterns across the visible surface. But on Betelgeuse, the scale is far greater. The cells of moving gas may be enormous. A single region of rising plasma can cover a vast part of the star. It can brighten one side. It can cool another. It can change the shape of the light reaching Earth. This makes Betelgeuse feel less like a solid object and more like a living ocean of fire. Not living in the biological sense, but alive with motion, alive with heat, alive with gravity, pressure, and slow instability. Its surface is not a clean edge. It is a restless boundary between the star and space. Above it, gas drifts outward. Below it, deeper layers continue to push energy upward. Between these regions, Betelgeuse swells and shifts. It is not perfectly round. It is not perfectly even. It is not the same from one moment to the next. Over time, astronomers have noticed that Betelgeuse has several rhythms. One rhythm lasts roughly hundreds of days. Another may stretch across several years. These rhythms do not behave like the ticking of a clock. They behave more like the breathing of something huge and old. A little brighter, a little dimmer, a little warmer, a little cooler, a giant inhaling and exhaling across the scale of seasons. To human eyes, these changes can be subtle on some nights. Betelgeuse appears strong and deep red. On other nights it seems softer, less certain, as if some part of its glow has retreated behind a thin curtain. For most of history, people saw only the general beauty of the star. They did not know its surface was moving. They did not know it was aging. They did not know that the red light on Orion's shoulder was the visible breath of a dying giant. Modern astronomy changed that. By measuring Betelgeuse carefully, night after night and year after year, scientists began to see that the star was restless. Its light carried information. Its color carried information. Its dimming and brightening were not random decorations of the sky. They were clues. They were messages from the outer layers of a star near the end of its life. This is one of the quiet wonders of astronomy. We cannot touch Betelgeuse. We cannot send a spacecraft to its surface. We cannot stand near its red atmosphere and watch its storms rise. But we can read its light. We can watch how that light changes. We can listen, in a sense, to the slow rhythm of a star too distant to make any sound. And the rhythm tells us that Betelgeuse is unstable. It tells us the outer layers are moving. It tells us the star is losing its old balance. Yet for a long time these changes still belonged to a familiar pattern. Betelgeuse was known to vary. It was known to pulse. It was known to brighten and fade. Its slow breathing was part of what made it itself. Then, near the end of 2019, something different happened. The familiar rhythm seemed to deepen into something stranger. The red giant did not merely fade a little. It dimmed in a way that caught the attention of the world. The old breathing of the star became a shadow, and in that shadow, a new question opened. What happens when the normal rhythm of a star suddenly breaks? For generations, Betelgeuse had changed in quiet ways. It brightened, it faded, it followed its slow and imperfect rhythms above Earth. Astronomers knew it was variable. They knew its light could rise and fall across the seasons. But in late 2019, the fading became different. It was not just another soft breath in the ordinary life of a red supergiant. It was deeper. It was stranger. It was visible enough that people who knew Orion began to feel that something in the sky had shifted. Betelgeuse, the red shoulder of the hunter, was growing dim, night after night. Observers watched the star lose brightness. The change was not sudden like a flash. It was slow enough to feel almost unreal. A familiar light became uncertain. A star that had always seemed confident in its place began to look tired. For many people, this was the first time Betelgeuse felt truly alive. Not alive as a creature is alive, but alive as a star can be alive. Changing, aging, moving through a process too large and slow for the human mind to easily hold. The timing made the mystery feel even stronger. Betelgeuse was already known as a star near the end of its life. It was already expected to become a supernova someday, so when it faded so dramatically, the question rose naturally. Was this the beginning of the end? Was the giant finally preparing to collapse? Was the red star on Orion's shoulder about to become a brilliant new light in the sky? Across the world, telescopes turned toward Betelgeuse. Professional observatories measured its light. Amateur astronomers followed it from backyards, fields, rooftops, and cold winter nights. For a brief time, a single star became a shared human question. People looked up and wondered whether they were watching history approach from hundreds of light years away. But space is patient, and stars rarely explain themselves quickly. Betelgeuse continued to dim. By early 2020, it had reached one of the faintest points recorded in modern observations. The shape of Orion felt subtly changed. The red shoulder was still there, but it no longer seemed as strong. It was as if a shadow had crossed the face of the giant. And because Betelgeuse is so far away, even that shadow was ancient by the time it reached us. The light we watched fading had left the star centuries earlier. The event itself belonged to the past. We were not seeing Betelgeuse as it was in that moment. We were receiving a delayed message from a distant red atmosphere. This is one of the most beautiful and unsettling truths in astronomy. When a star changes, the news travels at the speed of light, and even light needs time. For Betelgeuse, that time is measured in centuries. So as people stood beneath Orion in 2019 and 2020, they were not simply watching a star dim. They were watching an old signal arrive, a message written long ago in red light, dust, and cooling gas. At first, the most dramatic possibility was the supernova. It was the idea that captured the imagination. A star dims. A star is old. A star is massive. Perhaps the core is close to collapse. Perhaps the final moment is near. But as astronomers gathered more data, the story became quieter and more intricate. The dimming did not look like the first step of a final explosion. It looked more like something had happened in the outer layers of the star. Something on or near the surface had changed. Part of the star seemed to have cooled. Material may have lifted away from the surface. As that material traveled outward, it may have cooled enough to form dust, and that dust may have drifted between the bright surface of Betelgeuse and our view from Earth. The giant had not gone dark because its heart had failed. It had hidden itself behind a veil made from its own material. This answer was less dramatic than an immediate supernova, but it was not less mysterious. In some ways, it was more intimate. A supernova would have told us the final chapter had arrived. The dust told us that Betelgeuse was still struggling through the late chapters before the end. It was still active, still unstable, still capable of changing its own appearance across interstellar distance. Imagine a star so large that its surface is not a quiet skin, but a turbulent Red Sea. Imagine enormous cells of hot gas rising from below. Imagine cooler regions spreading across the surface. Imagine a pulse or disturbance lifting material outward. The gas escapes into the star's extended atmosphere. It moves away, it expands, it cools. Tiny grains begin to form. A dark veil gathers near the star, and hundreds of years later, on a small planet orbiting a yellow sun, human beings notice that a red point in Orion has grown faint. This is the Great Dimming, not simply a loss of light, not simply a failed prediction of an explosion. It is the story of how a dying giant briefly concealed itself from the universe. The dimming also changed the way many people felt about Betelgeuse. Before that event, it was famous, it was beautiful. It was one of the brightest stars in the night sky. But after the Great Dimming, it became something more personal. It became a star people watched with concern. A star that seemed to have suffered something. A star whose future no longer felt abstract. The Great Dimming reminded us that even familiar things in the sky are not fixed. The constellations feel ancient and permanent because we inherit them from people who lived before us. But the stars inside them are not symbols carved into darkness. They are physical bodies. They have interiors. They have surfaces. They have atmospheres. They have weather of a kind we can barely imagine. They evolve. They shed material. They can surprise us. For Betelgeuse, the surprise did not end when its brightness returned. The star brightened again, but the mystery remained. The dimming had disturbed some of its known rhythms. It raised new questions about how red supergiants lose mass. It suggested that the outer layers of these stars may be more violent and fragile than they appear from Earth. It showed that a star can change its face without yet reaching its final death. And it left behind a quieter thought. If Betelgeuse could dim this much once, it could change again. Not necessarily soon, not necessarily in the same way. But the star is not finished revealing itself. It still breathes in Orion. It still glows through the dark. It still carries storms beneath its red surface. And somewhere around it, material once belonging to the star may still be drifting outward, cooling slowly in the silence. The Great Dimming did not answer the question of when Betelgeuse will explode. Instead, it opened a deeper question about what happens to a massive star before the end. It showed us that the final life of a red supergiant is not a simple waiting period. It is a time of motion, loss, instability, dust, and hidden change. The fading light was not the end of Betelgeuse. It was a sign that the giant was shedding part of itself into space. And if the Great Dimming was not the final explosion, what kind of event could make a giant star hide behind its own dust? The Great Dimming began as a mystery of light. A star faded, a familiar red glow weakened. A shadow crossed the shoulder of Orion, but the more closely astronomers looked, the more the mystery changed shape. It was no longer only about what Earth failed to see. It became a question of what Betelgeuse had done to itself. Somewhere on or near the surface of the red giant, something powerful may have happened. A disturbance may have risen from inside the star. A region may have cooled. A great mass of gas may have been pushed outward into the star's enormous atmosphere. And for a time, Betelgeuse may have thrown part of its own outer layers into space. This idea is called a surface mass ejection. The phrase sounds clean and technical, but the image behind it is immense. Imagine the skin of a star lifting. Imagine a region larger than many planets rising away from a red surface. Imagine hot gas pushed outward by forces moving through the body of a dying sun. The material does not vanish. It does not explode into nothing. It travels, it expands, it cools, and as it moves away from the star, some of it may become dust. That dust can gather like a veil. It can drift between the star and the distant eyes watching from Earth, and the star still burning behind it appears to fade. This is what makes the great dimming so haunting. It may not have been a sign that Betelgeuse was dying at that exact moment, but it may have been a sign that Betelgeuse was wounded. Not wounded like a creature, not wounded by impact or intention. Wounded in the quiet, physical way a giant star can be wounded by its own instability. Its outer layers are not tightly held. Its surface is vast and restless. Its atmosphere reaches far into space. Material can rise, drift, escape, and cool beyond the visible edge. A red supergiant does not end its life neatly. It loosens it, sheds. It gives itself away before the final collapse ever comes. On the sun, we sometimes see great eruptions of material. Solar storms rise from magnetic fields. Plasma arcs outward. Charged particles stream into space. But Betelgeuse is not the sun. It is older in its stage of life. It is vastly larger. Its surface is stranger. Its outer layers are more extended and more fragile. A disturbance on Betelgeuse can happen on a scale that makes solar storms feel small. The great dimming suggested that something enormous had been expelled. A piece of the star's outer atmosphere may have moved outward like a slow red tide. At first, it would have been hot. It would have glowed close to the star. But as it traveled farther from the surface, it would have cooled. Atoms and molecules could begin to gather into grains. A dust cloud could form from the star's own lost material. The star would still be shining behind it, but from Earth the light would be partly hidden. This is not the image of a star suddenly dying. It is the image of a star aging in visible waves. A star that has become so large that its own boundary is uncertain. A star whose surface and atmosphere are no longer separate in any simple way. A star that can cover itself with its own expelled breath. There is something almost gentle in that image, a red giant dimming behind its own dust. But the gentleness is only in how it appears from Earth. Near Betelgeuse, this would not be gentle at all. The scale would be beyond any storm on any planet. The movements would be enormous. The forces would be ancient and deep. Hot gas would rise from inside a star wider than the orbit of worlds. Cooler regions would spread across its face. Gravity would pull inward. Pressure would push outward. The whole outer body of the star would shift like a vast unstable sea, and from that sea, material could be lifted away. This is one of the reasons Betelgeuse is so important. It lets us study a phase of stellar death that is usually hidden. A supernova is bright. A supernova announces itself across the galaxy. But the years and centuries before a supernova are quieter. They are harder to see. They happen in dimming, dust, pulsing mass loss, and strange changes in brightness. Betelgeuse gives us a nearby example of this uneasy final stage. It shows that a massive star may begin preparing its surroundings long before the final explosion. It may send material into space. It may build a dusty environment around itself. It may change the way its own light escapes. It may transform the region around it before its core ever collapses. This matters because the material lost before a supernova can shape what happens later. When a massive star finally explodes, the blast does not move into empty space. It moves into a space already changed by the star's own life. Gas may be waiting there. Dust may be waiting there. Old winds and ejections may have carved structures around the star. The final explosion meets the history of everything the star has already released. In this way, Betelgeuse is not only heading toward an ending, it is preparing the stage for that ending. Every pulse matters. Every lost layer matters. Every cloud of dust is part of the future story. The great dimming may have shown us one moment in that preparation. A moment when the red giant lifted material from itself. A moment when its surface became unstable enough to change the light we see on Earth. A moment when a star hundreds of light years away seemed to cover its face. And still, Betelgeuse continued. It did not collapse. It did not become a supernova. It brightened again. The wound, if we can call it that, did not end the star. It simply revealed that the giant is not as calm as it appears. It revealed that beneath the red glow there are forces we cannot watch directly. Forces that move heat through the star. Forces that reshape its surface. Forces that lift material outward. Forces that disturb the old rhythm of its light. The great dimming was a shadow. But behind the shadow was motion. Behind the motion was instability. And behind the instability was the hidden interior of a star, approaching the last chapters of its life. To understand why Betelgeuse could shed part of itself into space, we have to move deeper. We have to look beneath the red surface. We have to imagine the layers we cannot see, the pressure we cannot touch, and the burning core we can only infer from light. What kind of hidden forces beneath the red surface could lift so much material into space? From Earth, Betelgeuse gives us only its light, a red glow, a changing brightness, a color that softens through hundreds of years of space before it reaches our eyes. But the light is only the surface of the story. Beneath that red surface, the star is hiding almost everything. We cannot open Betelgeuse. We cannot lower an instrument into its atmosphere. We cannot stand beside its outer layers and watch the deep heat rising from below. Everything we know must come from signs, from brightness, from color, from motion, from shadows, from the way its light shifts over time. And those signs tell us that the inside of Betelgeuse is no longer simple. A young stable star has a kind of balance. Gravity pulls inward, pressure pushes outward, fuel burns in the core, light escapes slowly through the body of the star for a long time. The star holds itself together in this quiet struggle. But Betelgeuse has moved beyond that calmer stage. Its core has changed, its fuel has changed, its outer layers have expanded far into space. It is no longer a star in the long middle chapter of life. It is a massive star living in its late red age. Inside, the structure is layered. The star is not burning one simple fuel in one simple place. As massive stars age, their cores become more complex. Different kinds of nuclear burning can happen in shells, one region around another, like hidden fires buried inside a giant. Each layer carries the memory of an earlier stage. Each layer is shaped by heat, pressure, gravity, and the remains of fuel already used. The deeper we imagine going, the more extreme the star becomes. Near the surface, Betelgeuse is cool enough to glow red. But deeper inside, the temperatures are far beyond anything familiar. The soft red color we see is not the temperature of the whole star. It is only the color of the outer light. The interior is a furnace hidden behind a quiet glow. This is one of the strange things about a red supergiant. Its surface looks cooler than the sun. But its body is enormous. Its power is vast. Its interior is still burning through the final possibilities of a massive star's life. The red surface is not weakness. It is the visible skin of something immense and unstable. Above that surface, Betelgeuse has an extended atmosphere. It is not a sharp wall. It is not a clean line where the star ends and space begins. The outer layers become thinner and more delicate as they stretch outward. Gas can drift far from the visible body. Dust can form in the cooling material beyond the main glow. The star seems to fade into space gradually. This makes Betelgeuse difficult to measure. Where is the edge of a star when its atmosphere spreads outward like a red mist? Where does the star end if its own material keeps drifting away? For a star like the Sun, we can imagine a clearer boundary. For Betelgeuse, the boundary is more like a breathing veil. It rises, it thins, it shifts, it releases itself into the darkness. Beneath that veil, huge currents move through the star. Heat from the interior rises toward the surface. Cooler material sinks back down. But because Betelgeuse is so enormous, these motions happen on scales that feel almost impossible. A single convective region may be larger than the orbit of a planet. A change in one region of the surface may affect the light we see from Earth. A cooling patch may help dust form nearby. Pulse moving outward may lift material into the extended atmosphere. This is why the great dimming could be both simple and profound. Simple, because dust may have blocked part of the light. Profound, because the dust was only the visible outcome of hidden motion inside a dying star. A shadow on Betelgeuse may begin as a disturbance far below the surface. A slight cooling may begin in the movement of vast plasma cells. A cloud of dust may begin as material lifted from the star by pressure, heat, and instability. From Earth we see the final effect, but the cause is buried inside a body we can never enter. This is where Betelgeuse becomes more mysterious, not less. Science can describe the layers. It can model the motions. It can compare observations with simulations. It can estimate how much mass the star may be losing. But the interior itself remains hidden. We are reading the breathing of a giant from across the darkness. We are watching the red skin of a star and trying to understand the heart beneath it. And that heart is moving toward a future it cannot avoid. Massive stars do not remain red supergiants forever. Their cores continue changing. Their outer layers continue loosening. Their balance becomes more delicate. At some point, the inward pull of gravity will win over the forces holding the core up. That moment is the beginning of the final collapse. Betelgeuse is not there yet, at least not in the light we have received. It remains between states, still burning, still changing, still shedding, still hiding most of its truth inside itself. This hiddenness is part of its beauty. The star is visible to anyone who knows where to look, yet the thing that matters most is invisible. The surface glows, the interior waits. The atmosphere drifts, the dust moves outward, and all around Betelgeuse, the space near the star may be more complicated than we once imagined. For a long time, we have told the story of Betelgeuse as if it were alone. One red giant, one dying star, one future supernova. But the universe often hides companions in the glare of brighter things. And if so much of Betelgeuse itself is hidden from us, could something else also be hidden near the star? For most of this journey, Betelgeuse has felt like a solitary giant, a single red star glowing on the shoulder of Orion, a vast aging sun breathing slowly in the dark, a dying world of plasma, dust, and ancient light. But in the universe, solitude is often an illusion. Many stars are not alone. They are born with companions. They circle one another. They exchange material. They disturb one another's atmospheres. They live separate lives, but their gravity ties their stories together. Sometimes the companion is obvious. Two stars shine beside each other. Their motions reveal a shared orbit. Their light can be separated and studied. But sometimes one star is so large, so bright, and so overwhelming that anything near it becomes almost impossible to see. A smaller companion can vanish inside the glare of the giant. It can be hidden not by distance but by brightness. Betelgeuse is exactly the kind of star that could hide such a secret. Its outer atmosphere is enormous. Its red light fills the space around it. Its surface is restless and uneven. Its brightness changes naturally. Its gas moves in ways that can disguise smaller patterns. To look for something near Betelgeuse is not like looking for a star beside a candle. It is like looking for a faint lantern beside a burning red horizon. And yet, scientists have considered the possibility that Betelgeuse may not be completely alone. There may be a smaller companion moving near it. Perhaps close enough to pass through its extended atmosphere. Perhaps close enough to disturb the gas around the red giant. Perhaps close enough to leave a trace without being easily seen. The idea is quiet, but beautiful. A small star moving through the outer layers of a sleeping giant. A companion crossing a vast red atmosphere like a boat moving through a dark sea. Behind it, gas could gather. A wake could form. A pattern could remain in the light and from Earth. Centuries later, astronomers might notice that Betelgeuse is not changing in a simple way. Its brightness may carry more than the rhythm of one star. It may carry the hidden motion of two. This does not mean the mystery is solved. It does not mean every strange pulse or dimming comes from a companion. Betelgeuse is already complex on its own. Its surface is turbulent. Its atmosphere is extended. Its interior is changing. Its outer layers can rise, cool, and release material into space. A companion, if present, would be only one part of a much larger story, but it would change how we imagine the red giant. Betelgeuse would no longer be only an old star waiting in isolation. It would be a system, a place of interaction, a giant whose final years may be shaped by another light hidden close beside it. This possibility gives the story a new kind of intimacy. The star on Orion's shoulder may have a secret neighbor, a smaller presence moving through the glow, something almost lost in the red vastness, something that could disturb the giant without ever becoming visible to human eyes. It is easy to imagine Betelgeuse alone, because from Earth we see only one point, but a point of light can hide many things. It can hide a swollen surface. It can hide storms larger than planets. It can hide dust clouds forming from expelled gas. It can hide a layered interior moving toward collapse. And perhaps, somewhere inside the glare, it can hide another star. The more we learn about Betelgeuse, the less it feels like a simple object. It becomes a place, a region, a red environment with depth, motion, and possible companionship. Its light is not only the light of a star, it is a message from an entire system we are still learning to read. And if a smaller star is moving through the atmosphere of Betelgeuse, could it be shaping the giant's final years? A giant star may look powerful enough to live and die by itself. Betelgeuse is enormous. Its red atmosphere stretches outward into space. Its light overwhelms anything faint and close. Its future seems to belong only to its own mass, its own core, and its own gravity. But stars do not always live alone, and when they do not live alone, their stories can become more complex than a single star's path through time. A companion star does not need to be larger than Betelgeuse to matter. It does not need to outshine the red giant. It does not need to dominate the sky around it. It only needs gravity. Gravity is quiet. Gravity does not announce itself with light. It works patiently across distance, across time, across orbits, repeated again and again. A smaller companion near Betelgeuse could pull gently on the outer layers of the giant. It could stir gas in the extended atmosphere. It could help shape patterns in the material surrounding the star. It could leave behind a wake, a subtle trail of disturbed gas moving through the red glow. From far away, we might not see the companion directly. We might only see the effect. A change in brightness, a rhythm that does not quite belong to the star alone, a pattern that repeats over years. Disturbance, hidden inside the light of something much brighter. This is how astronomy often works. The universe rarely gives us the whole object at once. It gives us traces. It gives us shadows. It gives us motions. It gives us small changes in light that point towards something unseen. Around Betelgeuse, the possible companion adds a new layer to the mystery. The red giant is already unstable. Its surface already moves in vast convection cells. Its outer layers already rise and fall. Its atmosphere already stretches outward like a loose red veil. Its material already escapes into space. A companion would not create all of this by itself. But it could disturb what is already fragile. It could shape the way gas moves near the star. It could influence how material is lost. It could change the rhythm of the giant's outer atmosphere. It could make Betelgeuse's old age less solitary and less simple. This is important because the final life of a massive star is not only about what happens in the core. The core decides the final collapse, but the outer layers decide what surrounds the star when that collapse finally comes. If Betelgeuse loses material before its supernova, that material will not disappear. It will remain around the star. It may form gas shells. It may form dust. It may create an uneven environment waiting in the dark. Then one day, if the core collapses and the supernova begins, the explosion will move into that material. The final blast will meet the history of the star's own losses. It will strike gas the star released earlier. It will light up dust the star made before death. It will interact with everything Betelgeuse gave away while it was still alive. This means the years before the explosion matter. Pulses matter. The dimming matters. The dust matters. The possible companion matters. The long, quiet changes before the end may shape the light of the end itself. A dying star is not only its final moment. It is everything it releases on the way there. This makes Betelgeuse feel less like a simple countdown and more like a living system in slow transformation. It has a hidden interior moving toward an unknown future. It has a surface that rises and cools. It has an atmosphere that may shed clouds of material. It may have a companion passing through its outer glow. It has a history written into the space around it. And from Earth, all of this arrives to us as a faint red light in Orion. A single point, a small ember, a familiar star. But inside that point, gravity may be weaving more than one story. Perhaps Betelgeuse is alone. Perhaps it is not. Perhaps its companion is only a small influence on a giant already close to change. Perhaps it is part of the reason some of the giant's rhythms seem strange. Perhaps future observations will reveal the hidden shape of this system more clearly. For now, the mystery remains gentle and unresolved. The sleeping giant may be breathing on its own, or something small and hidden may be moving through its breath. But whether Betelgeuse is alone or not, one question still waits at the center of the story. When will the giant finally explode? Every path through Betelgeuse eventually returns to one question: when will it explode? The question is simple, the answer is not. Betelgeuse is massive enough to end its life as a supernova. One day, deep inside the star, the final balance will fail. Gravity will take hold of the core, the center will collapse. A shock will move outward. The red giant will transform into one of the brightest events the sky can offer. But knowing the ending is not the same as knowing the hour. The universe does not keep time in human ways. A star can be near the end of its life by cosmic standards and still outlast entire civilizations. It can be unstable, it can dim, it can shed dust, it can pulse strangely, it can show us all the signs of age, and still the final collapse may remain far away. This is why Betelgeuse is so fascinating. It is not a star in youth. It is not a star in calm middle age. It is late in its story, but late for a star is not always close enough for human calendars. When people saw Betelgeuse fade during the Great Dimming, it was natural to wonder if the supernova had begun. The star was old. The star was massive. The star was changing before our eyes. The idea of an approaching explosion felt almost unavoidable. Yet the evidence did not point clearly to that conclusion. The dimming seemed to come from the outer layers, not from the final collapse of the core. It seemed connected to cooling, gas, dust, and material released from the star. It was a dramatic sign of instability, but it was not proof that Betelgeuse was about to die. This matters because the last stages of a massive star are hidden. We cannot see the core directly. We cannot watch the central fuel burn away. In real time, we cannot know with perfect certainty what stage the deepest interior has reached. We infer, we model, we compare brightness, size, temperature, motion, and chemical clues. We build possible histories, but Betelgeuse keeps part of itself beyond the reach of certainty. Some scientists explore whether the star might be further along than expected. Others argue that the evidence still supports a longer wait. Some models suggest thousands of years. Others allow for much longer. The range is wide because the final life of a red supergiant is difficult to read from the outside. The surface can mislead us. The atmosphere can hide things. Dust can change the light. Convection can disturb the measurements. A possible companion can complicate the rhythm. Even the star's true size and distance have carried uncertainty. Betelgeuse is close enough to feel familiar, but not close enough to surrender all its secrets. And so the most honest answer is calm. Betelgeuse will explode one day, but probably not tonight. Probably not tomorrow. Probably not in the sudden way headlines sometimes imagine. The Great Dimming was not a cosmic alarm bell. It was a clue from an aging star. It told us that Betelgeuse is unstable. It told us that its outer layers can change dramatically. It told us that a red supergiant near the end of life is not a quiet object. But it did not tell us the date of the final collapse. This uncertainty should not make the story weaker. It makes the story deeper. A countdown ends when the number reaches 0. A mystery continues because the answer remains hidden. Betelgeuse is not interesting only because it may explode. It is interesting because we can watch the long approach to that transformation. We can see the star aging. We can see it breathe through changing brightness. We can see it dim behind dust. We can search for traces of material leaving its surface. We can wonder whether a hidden companion is disturbing its outer atmosphere. We can study the life before the death. That is the quieter gift of Betelgeuse. It allows us to witness stellar old age. Not the final second, not the spectacular ending alone, but the slow unraveling that comes before. In human life, endings often feel sudden, but in the universe, an ending can be prepared over vast spans of time. A star may spend thousands of years shedding mass before it dies. It may shape the space around itself. It may build the environment into which its final light will expand. Its death begins long before the last collapse. It begins in the loss of balance. It begins in the swelling of outer layers. It begins in dust. It begins in the strange rhythm of a red star that no longer shines with the simplicity of youth. Betelgeuse reminds us that the universe is patient with transformation. Final supernova is waiting somewhere in the future. But the star is already changing now, or rather, the old light reaching us tells us it was changing centuries ago. Its present is still hidden in transit. What we call now is only what the light has finally delivered. Perhaps Betelgeuse has already changed in ways we have not yet seen. Perhaps the next signal is already traveling through space. Perhaps some future generation will look up and notice that Orion has shifted again. That is the strange tension of this star. It is visible, it is familiar, it is part of the night sky we can point to with a hand. And yet its true condition is separated from us by centuries of light. We do not watch Betelgeuse in real time, we receive it, like a message in red, like a memory from a giant, like a slow letter crossing the dark. One day, the final message will arrive. It may come long after everyone alive now is gone, or it may arrive sooner than expected, because the universe has no duty to match our estimates. When it comes, it will not ask whether we are ready. It will simply appear in the sky. The red star will change. The shoulder of Orion will no longer look the same. A familiar point of light will become something almost impossible to ignore. But until that day, Betelgeuse remains suspended between what we know and what we cannot yet know. It is not an immediate threat. It is not a promise for our lifetime. It is a sleeping giant in the last great season of its stellar life. Still glowing, still breathing, still losing dust to space, still hiding its core behind a red surface hundreds of light years away. And if the final light does arrive one day, what would Earth actually see? If Betelgeuse finally exploded, the first thing Earth would receive would be light. Not heat that could burn our oceans, not a shockwave that could tear the planet apart, not the end of life beneath our sky. Just light. Ancient light. Powerful light. Light from a star that had already died hundreds of years before the message reached us. For the people on Earth, the moment would begin quietly. Perhaps Orion would rise like it always does. The belt would appear. The familiar pattern would return above the horizon. And then, somewhere on the shoulder of the hunter, Betelgeuse would no longer look like the same red star. It would brighten. At first, perhaps only astronomers would understand what had happened. They would see the sudden change. They would measure it. They would compare it with old records. They would know that the long-awaited transformation had finally arrived. But soon, the change would belong to everyone. A point of red light would become a brilliant presence in the sky. The shoulder of Orion would shine with a new intensity. The familiar constellation would become unfamiliar. The old red giant would not simply be brighter, it would be transformed. A supernova is not like an ordinary flare. It is the final collapse of a massive star made visible across space. Deep inside Betelgeuse, gravity would have overwhelmed the core. The center would have fallen inward, the outer layers would have been driven outward. The star would have released an enormous flood of energy, and after traveling across hundreds of light years, that energy would finally reach Earth as a new light in the night. For a time, Betelgeuse could become one of the most remarkable objects in the sky. It might shine brighter than before by an unimaginable degree. It could become visible, even when the rest of the night is not fully dark. It might glow like a strange star that does not belong to the old map of heaven. People would step outside and look up. Some would know the science. Some would only feel the wonder. Some would remember seeing Betelgeuse before, soft and red, and realize that something ancient had ended. There would be no sound from the explosion. Space would carry no thunder to us. The supernova would arrive in silence, a silent brightening, a silent announcement, a silent change in one of the oldest patterns known to human eyes. This silence is part of what makes the image so powerful. On Earth, storms arrive with wind, volcanoes arrive with fire and ash, lightning arrives with thunder, but the death of Betelgeuse would arrive as a light in the sky. Without a voice, it would not shake the ground. It would not roar through the air. It would simply appear above us, as if the universe had opened a bright wound in Orion, and yet, that wound would not be close enough to destroy us. Betelgeuse is far away. Its supernova would be a spectacle, not an apocalypse. Earth would remain Earth. The oceans would remain below. The moon would continue its orbit. The seasons would continue. People would still wake, sleep, work, speak, and look up, but the sky would feel changed. For generations, human beings have inherited Orion almost unchanged. We learn its shape from those before us. We pass it on to those after us. The belt, the shoulders, the bright stars around the hunter. But after Betelgeuse explodes, that inherited shape would begin to lose one of its familiar lights. At first, it would become brighter than memory. Then slowly the brightness would fade. The supernova would not remain forever. It would rise to brilliance. It would glow. It would decline. Night after night, month after month, the new light would soften. What had been extraordinary would begin to recede. The universe would not freeze the moment for us. Even the death of a giant would keep moving. Eventually, Betelgeuse as we know it would be gone. The red star on Orion's shoulder would no longer return in the same way. The constellation would survive, but it would carry an absence, a place where a familiar ember once burned, a silence inside a pattern, a missing red light in the old winter sky. This is the emotional truth of the future supernova. It would not only be a scientific event, it would be a change in human memory. People who had grown up seeing Betelgeuse would tell others what Orion used to look like. They would remember the red star before the brightness. They would remember the night it changed. They would remember that for a short time, the sky carried the visible death of a giant, and then the memory would become part of the story of Earth. Just as ancient people recorded comets, eclipses, and guest stars, a future generation might record the final light of Betelgeuse. They might describe it in observatories. They might photograph it from mountains. They might watch it from cities washed in artificial light. They might look up from quiet fields, where Orion still stands more clearly against the dark. And somewhere in that human watching, the distance between Earth and the stars would feel smaller. Not because Betelgeuse is close, but because change had crossed the distance. A star had died, and we had seen it. Yet even then, we would not be seeing the death. As it happened, we would be seeing the arrival of the news. The final collapse would have taken place long before the light reached us. By the time Earth knew, the star would already have become something else. The present would once again be a memory. The sky would once again be late. This is why Betelgeuse teaches us patience. It teaches us that the universe does not arrive all at once. It sends itself in waves of light. Some waves come from young stars, some come from ancient galaxies, some come from stars in the last moments of life. The future supernova of Betelgeuse is already part of this slow cosmic language. One day, the message will come. One day, the old red light will be replaced by something brighter, stranger and brief. One day Orion will change, and when that brightness fades, what remains of a star like Betelgeuse? When the brightness fades, the story of Betelgeuse will not be over. A supernova feels like an ending because it is so sudden, so luminous, and so final to the star we once knew. The red giant disappears, the familiar light changes, the old shape of Orion loses something it carried for generations. But in the universe, destruction is rarely only destruction. A star does not simply die and leave nothing behind. It gives itself back to space. During the final collapse, the outer layers of Betelgeuse would be driven outward. Material that once belonged to the star would expand into the surrounding darkness. Gas would rush away from the place where the red giant had been. Elements forged inside the star would be released into the galaxy. Dust and plasma would spread outward like the remains of an enormous cosmic breath. For a while, the region around Betelgeuse would glow with the energy of the explosion. The expanding material would form a supernova remnant. It would not look like the old star. It would not have the same red stillness. It would become a growing cloud, a structure of gas, dust, shock waves, and light. The star would no longer be a single point on Orion's shoulder. It would become a memory unfolding into space. This is one of the deepest transformations in the life of the universe. A massive star spends its life holding itself together. Gravity pulls it inward. Heat and pressure push outward. For millions of years, the star remains a body. It has a center, it has layers, it has a surface, it has a name. Then, in the final event, that body is opened. The material is no longer locked inside the star. It becomes part of the galaxy again. Some of it may drift through space for immense spans of time. Some of it may mix with older clouds of gas and dust. Some of it may become part of future nebulae. Some of it may be drawn into new regions where stars are born. The death of Betelgeuse would not erase its matter. It would release it. This is why supernovae matter so much to the cosmic story. They are not only bright endings, they are engines of renewal. They help spread heavy elements through space. They enrich the galaxy with material that can later become part of new stars. Planets, moons, oceans, rocks, and perhaps even living things. A dying star can help prepare the ingredients for worlds that do not yet exist. This makes the future of Betelgeuse strangely gentle. Even after the violence of the explosion, the red giant will be gone, but its material will keep traveling. The atoms inside it will not vanish. They will move outward. They will cool. They will mingle with the dark. They will become part of the long circulation of matter through the Milky Way. In this way, a star is not separate from the universe around it. It is a temporary gathering. Gravity gathers gas, fusion lights it, time changes it, death releases it. Then gravity may gather some of it again. A star is a chapter in the life of matter, not the whole book. Betelgeuse began inside a cloud. It became a massive star. It burned brightly, it grew old, it swelled into a red supergiant. It shed material into space one day. It will explode. And after that, pieces of Betelgeuse may continue through the galaxy, long after the name itself belongs only to memory. This thought changes the feeling of the supernova. It is still an ending. It is still the death of a giant. But it is not emptiness, it is return. It is the star giving back everything it borrowed from the galaxy. It is the old red light becoming dust, gas, motion, and possibility. Perhaps some distant future cloud will contain material from Betelgeuse. Perhaps that cloud will collapse. Perhaps new stars will ignite inside it. Perhaps disks of dust will form around those young stars. Perhaps planets will gather from the grains. Perhaps one of those planets will cool beneath a young sun. Perhaps under a sky that does not yet have a name. Some part of Betelgeuse will rest inside stone, ice, atmosphere, or ocean. This is not something we can follow directly. The timescales are too vast. The paths of atoms are too complicated. The galaxy is too large. But the principle is simple and beautiful. Stars make and scatter the materials from which future worlds are built. Betelgeuse is not only moving toward death. It is moving toward becoming part of other things. The sleeping giant will one day disappear from Orion, but the substance of the giant will not stop. It will become a traveling inheritance, of a red star's final gift to the dark. And if the death of a star can become part of the birth of future worlds, what does that mean for the quiet sky above us tonight? And so we return to Earth. We return from the surface of a red giant. We return from its dust. We return from its hidden interior, its possible companion, its future supernova. And the long journey of its material through space, we return to the same quiet night where the story began. Orion rises again. The belt appears first. 3 stars in a line across the dark. The shoulders follow, the knees, the familiar outline, and there, still glowing with its soft red light, is Betelgeuse. It looks almost the same as it did before, a small ember in the sky, distant point, a star that seems still enough to trust. But now, after traveling through its story, it no longer feels simple. That red light is not just decoration in the night. It is the visible sign of a giant star in old age. It is the glow of a body so enormous that its outer layers would swallow the inner solar system if it stood where our sun stands. It is the light of a star whose surface rises and sinks like a restless ocean. It is the message of a star that has already shed material into the dark. It is the memory of heat, pressure, gravity, dust, and deep time. Betelgeuse teaches us that the night sky is not still. It only appears still because we see it from the brief shore of a human life. Stars move through their own lifetimes. They are born in clouds. They burn, they age, they swell, they fade, they lose pieces of themselves. And some, like Betelgeuse, wait in the long red season before a final transformation. When we look up, we are not seeing a frozen universe. We are seeing many different moments of many different lives. Some stars are young, some are dying, some have already died, while their last light is still traveling. Some have not yet revealed what they have become. The sky is a library of delayed messages. Every point of light is both an object and a memory. Betelgeuse is especially haunting because it is close enough to feel familiar. It is not an invisible star hidden in a distant galaxy. It is not a number in a catalog that only scientists know. It belongs to Orion. It belongs to winter nights. It belongs to the human eye. People have looked at it for thousands of years without needing machines. And yet even this familiar star keeps secrets. We see its old light. We do not see its present. We know it will one day explode. We do not know when. We know it has dimmed before. We do not know exactly how it will behave next. We know it is aging. We do not know how many more quiet centuries of red light will reach us before the final change. This uncertainty is not something to fear. It is part of the beauty of looking into space. The universe does not give us every answer at once. It lets us watch. It lets us wonder. It lets us receive the past slowly, one photon at a time. Betelgeuse reminds us that even the most familiar lights are alive with hidden processes. A star can look calm while its surface is changing. A star can look permanent while its core is moving toward collapse. A star can look lonely while another companion may be hidden in its glow. A star can seem like a point while holding storms larger than worlds. And one day, when Betelgeuse finally changes forever, the sky will carry that message to whoever is here to receive it. Perhaps it will not be us. Perhaps it will be people thousands of years from now, standing beneath a different world with different cities, different languages, and different dreams. Perhaps they will look up and see Orion brighten in a way no one alive today has ever seen. Perhaps they will remember that the red star had been watched for ages. Perhaps they will understand that they are witnessing not only death, but release, the end of one star's body, the beginning of its material's next journey. Until then, Betelgeuse remains. It glows quietly. It breathes in old rhythms. It sends us light from a past we cannot touch. It waits in Orion like a sleeping giant, whose dream is written in dust and fire. And we, for a little while, are allowed to notice it. We are allowed to stand on a small world beneath a dark sky and understand that nothing above us is truly fixed. The constellations are stories we draw between stars, but the stars themselves have stories deeper than any shape we give them. Betelgeuse is one of those stories, a red giant, a fading mystery, a wounded surface, a possible hidden companion, a future supernova, a source of dust for worlds that do not yet exist, and perhaps this is the quiet lesson it leaves behind. The universe is not finished. It is still changing. It is still becoming. It is still turning old light into new questions. Tonight, Betelgeuse may look like a small red point on Orion's shoulder, but now we know that inside that point is a vast and unfinished journey, and if even the stars are slowly changing above us, what else, in the quiet night sky, have we not yet learned to see?